So this is Algebra 1, Semester 1. It's a unit called Systems. It's the 4th unit. And it's a lesson called Solving Systems Algebraically Practice. It's lesson number 6. It's on creatormath.com under the Algebra 1 tab. You might have to Google creatormath.weebly.com to find the site. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So typically during these videos I try to show you how to find those notes because that can be difficult for students. Typically once they find it the first time they're able to get back to it, but it can be annoying to not be able to find those notes. Alright, so let's see if I can show how to do that. Alright, so there's the name of the site, creatormath.weebly.com. Type that into Google. If you do and things are working right, which I hope they are, okay, you're going to, here's what the home page looks like, right? If we get there, that's what it is. If you have any questions on your composition book, you guys, which I know you do because it's a complicated thing, scroll down under this picture and you will see the words composition book. Read all of those directions, watch all of those videos, adhere to the turn-in dates, and put things on the right pages where they belong, all right? Including the notes, which we're going to go to now. So we're going to switch to the class tab to get the notes. Under the class tab, you're going to find 5 things. Number 1, the notes. Number 2, the practice sets, like we're about to do one now. Number 3, the video of the practice set, like we're about to make, well, like we're making right now. Number 4, the page numbers on which the notes go. And number 5, the vocabulary, as well as maybe some other things. Right here is a PDF, a complete PDF of all the vocabulary we will use this school year. It is downloadable to your device. And it is searchable. Just Google, how do I search a PDF on whatever type of device you're using, and follow those directions. It's a little bit different depending on what you're searching it on, what kind of device. And then the other thing I would say is if you're not getting 100% on your vocabulary practices, you may not know that this PDF exists. The whole point is for you to look up words on that PDF and get 100% on your vocabulary practices. It just helps you engage in the vocabulary a little bit more, okay? So next, we're going to find the all-important semester. This would be the semester you're in, or for the sake of this video, the semester of the video we're making. So under the semester is the table of contents for that entire semester. The table of contents are so important that I ask you to write the entire table of contents on the pages 2 through 6 of your composition book. Why? Because the table of contents has the page number of where everything goes. And I know this is hard to understand, but I got to grade like 180 of these comp books 5 times every semester, right? So I need to turn to a certain page and see a certain piece of material there, a certain type of notes. I can't just search your book for notes, right? So I ask you to please be deliberate. Please follow these page numbers. Number the pages like the video on the home page. Put the notes on the right pages so I can just go through the book quickly, right? Even if you're taking a video of it during COVID here. You're taking a video of the comp book and submitting that video, and I can just watch the video and grade your comp book very easily. I can see each page number, and I can see what's on it, and I can go, yes, check, 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 check. This student has all the requirements, okay? Next, we go down to the systems unit. This is a unit. There's lessons within it. This is lesson number 6 we're on. So actually, this one's a little bit out of date, and I will go back and fix this. It says to be determined. It should say solving systems algebraically. Okay, and I'll make a note to myself here. Update, I'm going to call it the TOC for table of contents. But it'll say the right title will be solving systems algebraically. These are the page numbers on which the notes go, and I'll link the notes to this word. The problem set we're doing now is linked here, and the video will be linked here when it's all done. Okay, so by the time you get to look at this, this should be updated for you, and you'll see a blue link here, a blue link here, and a blue link there. All right? With that said, there's not much to look at for notes because we don't have them right now. But let's delve into the problem set and go ahead and solve these anyway. So what's a system of equations? It's 2 equations on the same graph. And it might be 2 or more equations. In Algebra 1, we're just going to do 2 equations. So if you've got a graph x and y, right, the Cartesian coordinate system, and you've got a line here and a line there, that would be 2 graphs on 1 Cartesian coordinate plane. And the next question is going to say, what is the solution to a system of equations? The solution is where these 2 graphs cross or intersect, right? That's what we want to know. That's the fun part of a system. So a system's two or more graphs on the same graph. The solution is where the two equations cross or intersect, that is, have the same solution. And that explains why it's so exciting to us math teachers, right? Is that at this point, the solutions or the points on this line and the points on this line come into convergence here. They match each other. The solutions to both lines are the same at this point. We love that, okay? And it tells us different things about if you're in economics, right, and you're making money this way and you're losing money this way, the break-even point is where those two graphs cross, right? Break-even is, think of a business. You spend $100 to go buy materials. You've lost money right now, right? But once you make $100 back, now you're back to zero. You're back to breaking even. You haven't lost anything and you haven't made anything. All right, so now you make $1 more, that becomes profit. So this idea of break-even point, how many items do we have to sell? Or we have to sell $100 to break even. After that, everything's profit, and now we're, going to the bank. So that's where some of these concepts come into play. Right now, we're just doing the technical side of it and trying to see how to solve for that point. And this is the lesson number 6 in this, so we've done other lessons to build up to this. Using algebra to find the solution of the two equations, y equals x plus 1 and y equals minus 2x plus 4. Well, so to solve this algebraically, we have to have this idea that at this point, the solution to these two things are equal. Okay? They have the same solution. That means equal in math. All right, so what are we going to do to solve this algebraically? The y values must be the same at that point of intersection. So y equals y at that point. Well, y equals x plus 1 on this side, and y equals negative 2x plus 4 on this side. They must be equal to each other. Now we're going to solve for x. So let me add the two x's to both sides. And again, this is equation solving techniques, which are, again, should be familiar to you. So it disappears from the right, and when I say the right and the left, right, there's a center line down. The equals 2x plus x is 3x plus 1 equals 4. Minus 1 on both sides. Let's go up over here. Can I still see it? Yep, you can still see it. So the 1's disappear. I got 3x on the left equals 4 minus 1 is 3. Divide both sides by 3, and x equals 1. So at this solution point, x equals 1. Let's just look at the answer choices. The only choice with x equal to 1 is this first one here. So I already know the answer. They didn't make it that difficult for us. This is out, out. Why? They say x is 2 and x is negative 2. That's not true. We know x is 1. Now, how would we check this y? Now we take either one of these equations, y equals x plus 1, and we plug in the value of 1 we found here. We get y equals 1 plus 1, y equals 2. At the point of x equaling 1, y equals 2, and we get a coordinate location, right? 1, 2. So in this graph, 1 is on the x, 2 is on the y. Here is the point where those two graphs cross. And if you go back and literally graph these, which we could do probably very quickly here. In fact, let's do it on Desmos. Let's go ahead and check it on Desmos. Go here. How do I do this? Here. There we go. There we go. Forget how to use my phone. All right, so let's type in the two equations they've got here. See, x plus 1. So we're going to say y equals x plus 1. There's our first. And then we're going to do a second, tap below it, and say y equals negative 2x plus 4. Y equals negative 2x plus 4. There we go. So here's our system of equations, which is two graphs, two lines graphed on the same plane, right? And we're looking at this point right here. Where do they cross? Okay, so we're going to tap it twice, and it literally shows us 1, 2. So I didn't need to do all this algebraically. I can do it other ways. I can find it graphically and straight on Desmos. That's on purpose, you guys. You should be able to check your work. But this is how you solve it algebraically, and you need to know how to do this. Given the idea that y equals y, you can just put them equal and solve for x, plug that back into either one and solve for y, 1, 2. Okay, let's do it again. I think they give us 2 more examples, so it's not too long of a practice, but each one takes a while. So we're going to do the same thing. We're going to put them equal to each other. 4x minus 1 equals negative x plus 9. I'm going to add x to both sides. Okay. I'm going to get 5x minus 1 equals 9. I'm going to add 1 to both sides. 5x equals 10. I'm going to divide both sides by 5. Okay. X equals 10 divided by 5 is 2. So I know that x equals 2. Go back over here. There's none that equals 2. I already know the answer. But let's plug it back into either one of these. Y equals 4x minus 1. Y equals 4 times the x is 2. Okay. So 4 times 2 minus 1. So y equals 8 minus 1. Y equals 7. So the coordinate location is 2, 7 right here. All right. Check. And how quickly can we check if it's 2, 7? 4x minus 1. Minus x plus 9. Okay. Double tap. 2, 7. 2, 7. Ooh, we can almost see it. There it is. 2, 7. Check. All right. So we checked our work. And this goes into a coordinate of 2, 7. That's what we're looking at. The x is the 2, the y is the 7. Let's do one more. Here we go. All right, use algebra to find the solution. So we're going to take 2x minus 3 right here, put it equal to negative x minus 9. Add x's to both sides. 3x minus 3 equals negative 9. Add 3 to both sides. 3x equals 9 minus 3 is, whoops, it lagged a little bit there. Sorry about that. Minus 9 plus 3 is minus 6 divided by 3, divided by 3. X equals minus 2. So x equals minus 2 out, out. It's got to be this answer. So my internet's having trouble keeping up. X equals minus 2. That's right here. Just pick any one of them. Y equals 2x minus 3. So y equals 2 times minus 2 minus 3. We got this from here, right? That's what x is. So minus 4 minus 3. Y equals minus 7. Check. Right? See the minus 7 for y. And on this one, let's not use Desmos, right? Let's graph it. Maybe. 1, 2, 3, 4, 5, 6, 7, 8, 9. Put a point. That's right here. Minus 9. Go to minus 1 and over 1. Okay, here's this graph. Okay, am I still on the screen? Yep, so there's one line. And 2x minus 3, 1, 2, 3. And it's going to go up 2 over 1, up 2 over 1 right here. So we're going to go like this. All right, and this is freehand, you guys. So let's see if I can tell what this is. 1, 2, 3, 4, 5, 6, 7, 8 maybe? So, you know, this is harder, you guys. It's supposed to be going through minus 7 here. And it's supposed to be going through minus 1, 2. And so my freehand ain't so great. And I might now say, well, I don't know enough from that. Let's use Desmos, okay? I can only do so much freehand, and this one's a little bit more complicated, and my freehand ain't cutting it. And sorry to say, isn't cutting it. All right, 3. Negative x minus 9. Whoops. Negative xy equals negative x minus 9. There we go. Okay, why do I have 2? Get rid of this. There we go. So 2x minus 3, good. Double tap here. Negative 2, negative 7. Check. Okay? So my hand graphing didn't do so good. I couldn't prove it, but I can go to Desmos and prove it. All right? Make sure you're matching up the title of this video with the practice set you're doing. Otherwise, it's not going to make much sense. This is Algebra 1, Semester 1. It's a unit called Systems. It's a lesson called Solving Systems Algebraically Practice. And it's lesson number 6 in unit number 4. Okay? It's on creatormath.com under the Algebra 1 tab. Hope this helps.